I want to thank you all for joining us tonight. My name is Sandra Stone, and I'm the Regional Chancellor here at the University of South Florida, Sarasota-Manatee. We're delighted to host this program, and we're really happy that all of you came to join us and hope that you're enjoying your time on our campus. So if you've been here before, welcome back. If you've never been here before, welcome. And I hope you take a few minutes afterward to walk around a little bit and see how pretty it is. So thank you. This speaker series allows us an opportunity to engage the faculty, staff, students, alumni, and our community in cutting-edge conversations with experts on subjects that mean something in our lives. Tonight's event is one of a series of events that we're hosting as part of our year-long 40th anniversary celebration. So there are some other events coming up throughout the year. We hope you'll continue to join us and participate in the conversations. To get things started tonight, I want to welcome Dr. Jane Rose, the Dean of the College of Arts and Sciences, and she'll take it from there.
I also get my turn at welcoming you, and I'm very happy to do so. Throughout the year, the colleges host what we call our knowledgeable speaking series, and we're very happy to be hosting Dr. Aubrey DeGray as our College of Arts and Sciences knowledgeable speaker. Just explaining something about the College of Arts and Sciences, we are an interdisciplinary academic community. We have in all about 40 full-time faculty, augmented by about 30 very loyal and capable adjunct faculty. And we have a wide variety of disciplines, but what binds all of our disciplines, really, and the faculty is a commitment to the study of human ideas and experience, critical inquiry about the human experience, creative expression, and open discourse. Dr. Kathy Black exemplifies these values in her important scholarly contributions in the field of gerontological social work. And she also exemplifies USFSM's and the College of Arts and Sciences' commitment to civic engagement and applied learning in her current role leading the community initiative called Age-Friendly Sarasota. For those of you who aren't aware, Age-Friendly Sarasota seeks to build upon the community's assets and citizens' aspirations to optimize active, healthy, engaged living for people throughout their lifespan, focusing mostly on the far end of the lifespan. Age-Friendly Sarasota is Florida's first World Health Organization age-friendly community. This is important, and USF Sarasota Manatee and the College of Arts and Sciences are proud to be a partner in this effort. Now let me introduce to you Dr. Kathy Black, who will welcome the speaker.
Thank you, Dr. Rose. Thank you, Dr. Stone. Glad to see everybody here. And I am so honored to have Dr. Aubrey DeGray with us. In several of our classes, the students watch videos, his TED Talks. It's had millions of hits. And our physical changes in aging class, our ethical and legal issues class. And we actually have quite a few students in attendance tonight. And so we're really honored to hear from you. Before I introduce Dr. DeGray, I would like to just let everybody know that this room is hearing loop. It has a hearing loop, and so please know that if you need that. Also, the bathrooms are located right in back of this room, and it was chilly in here a few minutes ago, but I think with more people and it's the temperature's gotten nice. Dr. DeGray will speak for about 45 minutes, and then we'll be taking questions through cards that that are up here, and if you just raise your hand at some point and you need a card and you want to send up a question, we will sift through those at the end. Following the question and answer period, there'll be a short reception out in the area, and so we'll look forward to those of you who want to talk more with Dr. DeGray then. And now I'd like to introduce our very esteemed guest here. Dr. Aubrey DeGray is a biomedical gerontologist based in Cambridge, England, and Mountain View, California. He is the Chief Science Officer of the SENS Research Foundation. It is an acronym, and he'll share with you more what the words mean. It is a 501c3 charity dedicated to combating the aging process. He is also the editor-in-chief of Rejuvenation Research, the world's highest impact peer-reviewed journal focused on intervention in aging. He received his BA in computer science and PhD in biology from the University of Cambridge. His research interests encompass the characterization of all accumulating and eventually pathogenic, which means disease-creating, molecular and cellular side effects of metabolism or damage that constitute mammalian aging, and the design of interventions to repair or obviate that damage. Dr. DeGray is a fellow of the Gerontological Society of America and the American Aging Association, and sits on the editorial and scientific advisory boards of numerous journals and organizations. Dr. DeGray's talk will be Rejuvenation Biotechnology, the sweet spot between prevention and treatment of age-related ill health. Thank you, Dr. DeGray.
All right, well, thank you very much, Kathy, for that lovely introduction, and thank you all for your attendance. This is my first visit to Sarasota. I must say I like it here a lot, and I am being extremely well looked after, so thank you all. I hope I'm going to be able to reciprocate over the next little while. First of all, I have been given to understand that this audience is very heterogeneous in terms of background and expertise and so on, that there are some biologists here, some gerontologists who work in social gerontology like Kathy and so on, and a number of people who are not in either of those camps, including members of the general public, not members of the university necessarily. And I'm going to try and tailor my remarks accordingly. I'm going to not get too desperately deep into the biology of what we do, though I am a biologist, and the organization that has been created around my work, SENS Research Foundation, is a biomedical research charity. I'm going to talk to some extent about that, though, because I think that in order to have a meaningful discussion about social issues and other aspects of aging and its manipulation that may concern you, it's absolutely essential to start from a solid and biologically justified background and foundation with regard to what aging actually is and what we can plausibly expect to do about it in the foreseeable future. And that is an understanding which is absolutely, utterly lacking in the wider world as of today, despite my best efforts. I assure you that anyone here who thinks they understand what aging is almost certainly wrong and will know it very soon. So this is the title of my talk. Rejuvenation biotechnology is a term that I use a lot. It emphasizes two things. Number one, that we are not talking about science here, we are talking about technology. The difference is very important. Science is all about understanding nature. Technology is all about manipulating nature. And of course, you can't manipulate nature until you understand it reasonably well, but nevertheless, the whole idea of technology, the practice of it, is very different from the practice of science. One treats evidence in a different way. One goes about things in a different way. And a lot of the reason why it's been so difficult to get things really moving in biomedical gerontology and rejuvenation biotechnology is because the field of gerontology with regard to the biology of aging has been dominated by people who are overwhelmingly trained as basic scientists rather than as technologists. I also want to emphasize the thing that I'm saying as a subtitle here, this idea that rejuvenation biotechnology is somewhere between prevention and treatment. I won't go into explaining what I mean by that right now, but you will see over the next 10 minutes or so how that subtitle really encapsulates what we do and why. So I'm going to start here. You know, talks are often supposed to be like this, right? They're saying, okay, why do we do what we do? How are we doing what we're doing? And what are we doing? And this is the why. It's pretty straightforward. Aging is not a good thing. It is fundamentally bad for you. It kills people. In fact, it kills a fabulous number of people. More than 2/3 of all deaths are due to aging. In other words, don't laugh, this is the fact, right? More than 2/3 of all deaths are due to causes that predominantly affect people who were born a long time ago. And that means they are part of aging. So it is the world's #1 cause of suffering, and that is why I work on it. When I was an undergraduate back in the 1980s, and for the next decade or so, I was not a biologist at all. I was a computer scientist. I worked in artificial intelligence research. And the reason I did that was because I thought that actually a really important thing that we ought to be doing something about is the tedium of having to get up and do stuff that we would rather not in order to keep the world going round. If we had machines that could do all that sort of bullshit for us, then we would be able to have more fun, basically, enriching each other's lives. And so I felt that this was a very important thing to work on. And I still do, you understand. It's just that when I was around 30, I discovered to my utter horror that the one problem which I thought was even more serious than that, namely the problem of aging, was not viewed as a serious problem by more than a tiny proportion of the human race. And I felt that that needed to change, and so I switched fields. So anyway, yes, we at Sense Research Foundation are not in favour of aging. So, that was easy. Now, the rest of the talk will consist of, first of all, explaining the plan for how we are going to do something about aging, and then what, in other words, what we're doing already in terms of implementing that plan, what other people are doing, how this plan is gaining respectability and indeed rising to, I think, what we can call orthodoxy within the field. And after that, I'm going to discuss, in the last part of the talk, some of the social implications of all of this and why you ought to be supporting it, rather than perhaps thinking that it's an absolutely terrifying concept, which some people do. So, I'm going to start here. Now, I'm going to start by asking a question. This is a question that we all ought to ask ourselves, but actually it is kind of overlooked a lot. Why have we been so pathetically unsuccessful in medical research over the past couple of centuries in combating the diseases of old age? Because let's face it, over the past couple of centuries, we've been extraordinarily successful in combating infectious diseases that used to do in an awful lot of people. Being born 200 years ago was very risky. It was. The fact is, you only had about a 2 in 3 chance of living to the age of 1. Even in the wealthiest nations in the world, more than 1/3 of babies died before the age of 1. And of course, there was death in childbirth and so on and so forth. And there's virtually none of that now in the USA, or indeed in any other even respectably wealthy nation. And the reason, of course, is that we developed a really primitive, but nevertheless perfectly sufficient level of understanding of what was going on to be able to stop it going on. We worked out that hygiene was quite a good idea. We developed these fairly elementary things like vaccines and antibiotics and mosquito nets. So all in all, that was straightforward. So what's the problem? Why have we made so much less progress against aging? Well, most people would say this. Don't worry, you're not supposed to be able to read this slide. The point here, of course, is that aging is awfully complicated. There's an awful lot of things that go wrong with us during late life, and they go wrong all more or less at the same time, and they interact with each other, so they exacerbate each other. The whole thing is a network, it's a real mess, okay? And so most people would say, well, this is fundamentally the problem. It's just so complicated that we haven't figured out how to address it with medical technology of the 21st century. And to some extent, that is the correct answer. But I do not think that it is the main answer. There's an even bigger answer. In order to introduce that, I'm going to take a step back first, and I'm going to define what aging is. Most people actually get this wrong. Most people think that aging is, first of all, a mystery. They think it's a mysterious phenomenon that people don't understand. And secondly, they think it's some kind of, natural, inevitable phenomenon like, entropy. That's another example of complete bullshit. This is the actual definition of aging. Aging is simply the same phenomenon in the human body or in any other living organism as it is in a simple man-made machine, like a car or an aeroplane, anything like that. It is simply the accumulation of damage that occurs as side effect, as a consequence of the machine's normal operation. Any machine, it's not a fact of biology, this is a fact of physics, that any machine with moving parts is going to do damage to itself as a side effect of its normal operation, and that damage is going to accumulate. Now, we don't suffer functional consequences, not significant ones anyway, from the accumulation of that damage until middle age. But that doesn't mean that the damage is only starting to be created in middle age. The damage starts to be created from conception. It's just that the body is set up to tolerate a whole bunch of that damage, just in the same way that a car is set up to tolerate a certain amount of damage before it starts to go wrong. But only a certain amount. And eventually the damage that we are creating in our bodies just in the course of living accumulates to a level that exceeds that, and that's when our physical and mental functions start to go downhill and eventually to cease entirely. That's what aging is. It's no mystery. It's a really simple thing. So, what does that mean? Well, first of all, let's condense it into 3 words. Metabolism causes damage, causes pathology. Metabolism is the word that biologists use to denote the entirety of what the body does to keep us alive from one day to the next. All this network of processes. Damage is what I've been talking about. Lifelong, starting before we're born, damage accumulates as a result of metabolism. Eventually, late in life, that damage gets to a level of abundance that the body can't tolerate, and that's when the pathologies of old age start to emerge. I can see some people taking notes, so I should actually mention, in order to save you all time, that I have made this PowerPoint available to the university, and they can certainly freely distribute copies to anyone who wants it. Just send them an email. So now, this is what aging is. So, what does that mean in terms of intervention? Well, first of all, I'm going to tell you what it doesn't mean. This here that I've got, this table here, is the kind of answer that you would get if you asked a typical person to classify the types of ways that people can get sick. They would say, well, there are various types of disease. There are infections, communicable diseases, like the ones in column 1. There are genetic diseases that a small proportion of us are unlucky enough to inherit from our parents. That's the things in column 2. And then there are the chronic, progressive diseases of old age, like Alzheimer's, most cancers, atherosclerosis, osteoporosis, and so on. And then most people would say that there's this 4th category out in the stratosphere somewhere, something completely different called aging itself, which consists of these rather non-specific things that we don't call diseases. Things like sarcopenia, that's the loss of muscle as we get older, or immunosenescence, that's the decline in function of the immune system. People think of those as aging itself. And there's this big black line in people's heads. They think that aging is something really, really different from all of these types of disease. Now, that's incorrect. And the reason I'm belaboring it so much is because it is extremely damagingly incorrect. The correct way to actually classify the ways to be sick is like this. The columns are all the same as they were on the previous slide, but the big black line is in a different place. That is critical, because what that denotes is that the things in column 3 are actually parts of aging. They are basically not different in any sense other than semantic from the things in column 4. Whereas they're completely different from the things in column 1, the infections that we can actually, in principle, cure, and in practice cure in most cases these days. In column 3, we have aspects of aging. We have things that are the result of the accumulation throughout life of damage, and the only difference between column 3 and column 4 is that column 3 consists of things that, for whatever reason, we choose to give disease-like names to. That is all. Now, why is that so important? This is why. If you get that wrong, if you think that the things in column 3 are like the things in column 1, then you are probably going to end up thinking that you have a chance of curing the things in column 3. And that's what geriatric medicine is all about. The billions and billions and billions of dollars that are spent around the world today trying to alleviate the ill health of old age is overwhelmingly spent on what we can call geriatric medicine, going after the pathologies of old age in just the same way as we go after the infections of early life. And it's obviously hopeless. If you just look at this diagram, it's completely obvious that it's never going to work, because the pathologies of old age are the consequence of something that's continuing to accumulate, hello. So it's built into the definition of geriatric medicine that it's going to become progressively less effective as the patient gets older. And it's better than nothing, but only marginally better than nothing, and it's never going to be any better than that. And yet, the amount that gets spent on it is absolutely insane. And it carries on getting spent, you know. I mean, you know the famous aphorism from Upton Sinclair. He said that it's terribly hard to get someone to understand something if their salary depends on not understanding it. It's a classic example of that. So, now, I am not the first person to point this out, though I may be pointing it out in rather more undiplomatic language than most people do. The fact is, for more than 100 years now, people have actually figured out that geriatric medicine was a mug's game, and that the only way you're really going to be able to extend healthy life and postpone the pathologies of old age is by intervening preventatively, by trying to get in earlier on, before people are sick, and stop this process from behaving the way it normally does. And that's where gerontology was born. In the early years of the 20th century, people started thinking about how we might be able to clean up metabolism. In other words, slow down the rate at which it creates this damage in the first place. If you can do that, fantastic. You are obviously going to postpone the age at which the damage reaches the level of abundance that's bad for people, right? Fantastic. Unfortunately, the gerontology approach has also been utterly unsuccessful, perhaps even more unsuccessful than the geriatrics approach. Bit of a shame, really. Why would that be? Well, a couple of reasons. First of all, people are not really very fond of preventative medicine. This approach of slowing down the creation of damage is obviously going to have a big effect only if it is implemented throughout life, so that the creation of damage can be slowed down throughout life. If you only implement it in middle age, when the person already has accumulated most of the damage that they need in order to get sick, then you're not going to gain very much by slowing down the creation of the small amount of additional damage. Unfortunately, there's another reason which makes the gerontology approach even more utterly hopeless, which is this. I told you that that pathologies of aging were complicated. Metabolism blows it away. Metabolism is ridiculously complicated. This, what I'm showing you here, is a simplified diagram of a small subset of what we know about how metabolism actually works. And as you can see, it's a complete joke. Those of you who understand software will recognize the similarity to utterly uncommented spaghetti code, right? There is no way in the world that one's going to be able to go in and tweak this network of processes in such a way as to stop it doing the thing we don't want it to do, the creation of damage, without also stopping it from doing stuff that we need to do to keep us alive. It's just not going to happen. And that, of course, is an understatement of the real problem. The real problem is not that this is a simplified diagram of a small subset of what we know about how the body works. The problem is that it's a simplified diagram of a small subset of what we know about how the body works, which is completely dwarfed, as any biologist will tell you, by the utterly astronomical amount that we don't know about how the body works. And that's even ignoring all the stuff that we don't even know that we don't know. So, forget it. But, of course, I wouldn't be standing here if that were the end of the story. It's not the end of the story, because there is a third approach, a completely different way to go about postponing the pathology of old age, which is not about slowing down the process whereby metabolism creates damage, and also not about slowing down the process where damage creates pathology. Instead, what we do is we separate those two processes from each other. We uncouple them by going in and periodically repairing that damage, so that even though it's being created still, it doesn't accumulate over long term to the point where it becomes pathogenic. And that is the approach that Sensory Research Foundation follows. That is the definition of rejuvenation biotechnology. Now, you can see, first of all, why it's the sweet spot between prevention and treatment. Gerontology is the far end, the preventative end. Geriatrics is the treatment end. This is somewhere in between. But also, you can probably see why it's got so much more of a chance of success. Because the damage that we're talking about turns out not to be nearly so complicated as either its causes, metabolism, or its consequences, pathology. In fact, it turns out that if you think about damage and you look closely at what we know about what types of molecular and cellular changes happen in the body throughout life that eventually contribute to the ill health of old age, then they can be classified into just 7 major categories. Here are the categories. This classification is something that I came up with more than a decade ago. Other people have more recently tried to reinvent this thing as if it were their own idea, and they've come up with more or less the same thing. So, this is really standing the test of time. And as you can see, these categories are very simple. They're broad, but that's okay. You'll see why in a minute. And they're very concrete. They're down-to-earth, straightforward, concrete, real biological phenomena. Look at the top one, cell loss. What is that? That's simply cells dying and not being automatically replaced by the division of other cells. That's all it is, right? So, of course, if that's happening in any particular organ, then the number of cells in that particular organ is going to diminish over time. And eventually there's not going to be enough cells for the organ to do its job. Parkinson's disease is a fine example of that kind of damage. There's a particular part of the brain called the substantia nigra, in which neurons actually turn out to die more rapidly than most neurons die. And sure enough, after like 70 or 80 years of life, we've all lost perhaps 20 or 30% of the neurons in that particular region of the brain, which is a really important region for creating a chemical called dopamine. Some people are unlucky and they lose those neurons a little faster than that, so by the time they're 80, they've lost maybe 80% of those neurons, and that's too many, and those are the people who have Parkinson's disease. So I could go through the others. We don't really have time tonight, and anyway, it gets a bit technical. I'll go through one or two of them later on in a bit more detail. But that's the logic of it. Every single thing that we can point to that has some role in aging, in other words, that eventually leads to the pathologies of old age, whether the ones we call disease in column 3 of my earlier table or the ones in column 4, everything fits into this classification. And, I know this basically because it is standing the test of time. All of these 7 phenomena have been major topics of study by the biologists of aging for more than 30 years. Furthermore, I've been going out challenging my colleagues to actually extend this list for more than a decade now, and I've been getting away with it. So, I think we can pretty confidently say now that there isn't a category number 8 waiting to be found. So, that's the basics of the plan. Now I'm going to get into a bit of what we're doing about it, why a Sense Research Foundation exists, what we are actually spending your money on, and so on. And the fundamental answer, the simple one-slide answer, is this. For every type of damage in the left-hand side of this slide, we have a corresponding therapy, a generic therapy which can be used to repair, or in some cases to render harmless, all examples within the corresponding category. So in the case of cell loss, of course, what we're talking here about is stem cell therapy. Stem cell therapy is precisely that. It's a way to repair the type of damage that we call cell loss. We put stem cells into the relevant organ or into the body so that they can divide and differentiate to replace the cells that the body is not replacing on its own. If we go back to Parkinson's disease, there are now clinical trials underway doing exactly this. In fact, the first time this was done 20 years ago, it worked occasionally. It only worked occasionally because we didn't know very much back then about how to manipulate stem cells in the lab before transplanting them into the patient to be able to make sure that they were the right type of stem cell. Now we do, and we are very optimistic. And when I say we, I mean the community in general, not just my organization, that this is really going to deliver a cure for Parkinson's pretty soon. And the same applies to each of these other things, but the reason Sense Research Foundation exists is because the other approaches, the other maintenance approaches to the other categories are much less well appreciated, much less far along, and of course much less well funded. So they need to catch up. There's a lot of catching up that needs to be done for a number of these things. Now we're doing plenty on this. We had our first paper in Science magazine, the #1 science publication in the world, just 3 months ago, which is a key step towards our proposed therapy against hypertension. We've published something a few years ago, which I'm going to go into a little bit more in the next few slides, regarding atherosclerosis, of course the #1 killer in the Western world because it causes heart attacks and strokes. We're also going after something called amyloidosis, which is a disease that turns out to be the #1 killer of extremely old people. If you're lucky enough to get to, let's say, 105 or so, then that's the thing you're most likely to die of. And we have a whole bunch of other things going on. We're publishing more and more as our work progresses. One thing you may be thinking, though, is, well, hang on, why haven't I heard about this before? Why isn't the entire scientific community, or at least the entire biogerontology community, talking about this on stage and on camera all the time? Well, they increasingly are. When I was describing the way in which the maintenance approach departs from what I call the gerontology approach a little while back, a few minutes ago, you may have noticed that it was quite a dramatic departure. And of course, dramatic changes in scientific thinking don't always get accepted at once. It was actually a physicist, Max Planck, in the early years of the 20th century who made the famous statement that science advances funeral by funeral, which refers to the fact that the scientists who are responsible for the prevailing orthodoxy tend to be the ones in control of the funding of the scientists who are trying to update that orthodoxy. But the point is that this is now changing. The 25 people you see here are members of our scientific advisory board, and they are all world-leading luminaries in the various fields that we are bringing together with this rejuvenation biotechnology approach. And they're all on public record as giving extreme, unequivocal support to this way of going about things. It's also rather heartening that, as I mentioned a few minutes ago, other people are beginning to reinvent this and pretend that it's their own idea. A couple of years ago, a paper came out in Cell, which is another really high-profile scientific publication, in which, in their case, they decided there were 9 categories. It really doesn't make much difference. And similarly, they invented 9 different ways of going about fixing them. There is, of course, a significant overlap between their classification and ours. That is basically a bit broken, whereas ours isn't, but apart from that, it's fine. And, of course, the thing is that this paper, because it was written by grandees, is being cited literally about once a day, and so that's fantastic. You know, I seem to be in aphorism mode today, so let me also use the one that it says there's no end to what someone can achieve if they don't mind not getting the credit. So I'm fairly happy about all this. But the main thing is that we're actually in the lead at Sense Research Foundation in respect of actually doing something about all this, actually implementing the maintenance approach. Just for illustration, I'm going to spend a few minutes now on the category number 5 there, the one in purple. So you can see how it's described as intracellular junk. What that means is molecular waste products that are accumulating inside cells. This turns out to be the major cause of atherosclerosis, as I mentioned earlier, the #1 killer in the Western world, and also of a number of other important diseases of old age. Macular degeneration, the #1 cause of blindness in the elderly, is also caused by this. What do we do about it? Well, basically, everyone had given up on the whole idea that we could ever do anything about it until fairly recently. But about 17 years ago, I came along and suggested that we might be able to use some technology that gerontologists hadn't really thought about because it had never been used in medicine. It's actually a technology that we stole from environmental decontamination, believe it or not. There's a field called bioremediation, which involves identifying microbes, typically bacteria, that can break down pollutants. So you find microbes that can, for example, just eat TNT. And you can sprinkle them over a disused airfield that you want to build houses on, and you can get rid of the TNT so that the houses can be built and the kids won't die, right? And this is not just an academic concept. This is a thriving commercial discipline. So what I realized was that we could use this concept biomedically. We could identify such bacteria that could break down things that accumulate in the body to our eventual detriment. And then rather than injecting the bacteria into the body, that might have side effects really, let's not do that. Instead, let's figure out what genes those bacteria are using that allow them to break down these substances, and then let's add those genes, modified in such a way that they still work, to our own human cells, so that our human cells are enhanced in their ability to break things down, and they don't therefore get poisoned by the accumulation of intolerable quantities of garbage. It turns out to work. So in the case of atherosclerosis, this is the problem we're trying to solve. Atherosclerosis is caused ultimately by the accumulation in white blood cells in the artery wall of cholesterol and other lipids, other fatty deposits. And that is caused by the poisoning of those white blood cells with oxidized cholesterol. Macrophages, the type of white blood cell we're talking about here, are perfectly well equipped to process normal cholesterol. And in fact, that's why they are in the artery wall in the first place. But they are not equipped to process the relatively small amount of contaminant that is in the form of oxidized cholesterol. If they were, they wouldn't get the way you're seeing on this slide. But they do, and this is the beginning of atherosclerosis. So what we want to do is give these cells the ability to break down oxidized cholesterol and therefore not get poisoned by it. And we've done it. This is what we published a couple of years ago now. We found bacteria that could eat oxidized cholesterol. We found the genes with which they do so, and we were able to modify those genes with a lot of tinkering so as to be able to put them into human cells in such a way that they still work. What this slide is showing is that for a variety of different concentrations of oxidized cholesterol in cell culture, the bar on the right, which is the one which has been modified with our engineered gene, is taller than the other bars, which means that the cells are protected relative to cells that don't have our gene. These other things, what we call the negative controls, they are cells that don't have any modification, or they've been given an enzyme but it's the wrong enzyme, or they've been given the right enzyme but it's not targeted to the correct part of the cell, things like that. So it works. Now, we want to move this further along, but being a very poorly funded charity, we have not actually been able to make as much progress as we believe the science allows, like, for example, testing this out in mouse models of atherosclerosis. However, I'm delighted to say that about a year ago, one of our major funders, an entrepreneur from Arizona, decided that that wasn't good enough, so he formed a company. Just out of the blue, he formed a company, gave us 10% of the company, took our people, threw in a couple more people, and they're running with this technology now. This is the kind of tech transfer event that we want to have happen all over what we do. We do not exist for the sake of existing. We exist for the sake of solving the problem of aging. And we certainly believe that the way in which that's going to happen is by kickstarting a rejuvenation biotechnology industry, with the emphasis on the word industry. We want the private sector to get involved everywhere in this whole thing as quickly as possible. And we believe that what our role is to do the early stage proof of concept work that gets things to the point where the more visionary end of the investor spectrum are willing to get stuck in. So that's a great example. Now, that's all the science I'm going to give you tonight. I'm now going to talk about what this means for society and in particular for everyone in this room. So, some of you may have come across me in the media, and if you have, the chances are that you think I am interested in getting people to live forever, because that's what journalists like to tell you, because that's what you buy. It sells papers to be sensationalist, unfortunately, and I spend an awful lot of my time and effort disabusing people of the idea that I am all about getting people to live forever. But let me tell you what I am about. I'm about health. We at Sense Research Foundation are in the business of helping you to stay healthy. However, there is a bit of a catch. All people who work in medical research are in the business of helping you to stay healthy. And that means, because ultimately what kills most people is not being healthy, right? You die from being sick, yeah? What that means is that medicine has a side effect. Medicine causes you to live longer, on average. Of course, you might or might not be hit by a truck, but on average, you'll live longer if you have medicine than if you don't have the medicine. And the catch is that our medicine, the medicine that we're developing, will have a rather big side effect in terms of longevity. Because let's face it, nearly everyone in the industrialized world dies of aging now. In other words, they die of the ill health of old age. So if we can eliminate the ill health of old age in the manner that I've been describing to you today, then we're going to eliminate an awful lot of the risks that kill people in old age. And that turns out to mean that people are going to live really a lot longer. Now, to cut a long story short, what I'm describing on this slide is a concept that I've called longevity escape velocity, which comes down to one very simple fact. The therapies that we're working on today will not be a complete cure for aging. They will not eliminate all of the types of damage that the body accumulates in the course of being alive. But they will make a very good step towards that ultimate goal. And that step will probably give us an additional 30 years of life, something like that. And that means that people who come in, aged maybe 60 or 70, at the time that these therapies come online, excuse me, will be rejuvenated to such a point where they won't be biologically 60 again until they're chronologically 90. Think about that. 30 years of time that we've bought you if we get these therapies working. Now, think about how things were 30 years ago. Hands up anyone who had a cell phone 30 years ago. Come on. Right? So it's the same in medicine. Medicine advances like indescribably, like unimaginably in 30 years. So it's absolutely certain, as good a certainty as you want, that within 30 years, these therapies will have been improved to generate, let's call it Sense 2.0, such that we can re-rejuvenate you again, right, when you're chronologically 90 and biologically 60, so that you won't be biologically 60 for the third time until you're chronologically 150, and so on, right? The idea is that you keep one step ahead of the problem. The problem is becoming intrinsically more difficult as time goes on, but the solutions that are available to address the problem are advancing in performance, in sophistication by a greater speed than that. This is not the concept of accelerating change that my friend Ray Kurzweil often talks about. This doesn't need to accelerate. Just steady progress is perfectly sufficient to stay one step ahead of the problem. So this means that, yes, people are going to live just as long as they would if their risk of death did not go up at all as they get older. Today, as we speak today, your chance of dying in the coming year is about 10% greater than your chance of dying was in the year that's just finished. And that doesn't matter, that's independent of how old you are. That's true of every single person in this room. Younger people in this room have, obviously, a smaller chance of dying in the coming year than older people in this room. But it goes up by 10% per year of age, however old you are. It's an exponential function. If we eliminate that, then what we're saying is that your chance of dying if you're 60 will be the same as your chance of dying in the next year if you're 30. And that chance, the chance of dying if you're 30, is of course very low in the industrialized world. It's less than 1 in 1,000. So you do the maths, right? That means that most people are probably going to live into 4 digits, right? Which is a bit scary to a lot of people. It sounds like a very different world, and yes, it will be a very different world, but get used to it because it's going to happen. Now, how soon is it going to happen? Some of you, I bet, some of you are thinking, well, that's okay, I'm not going to worry because I'll be safely dead by then. Well, dream on, because fact is, it's going pretty well right now. I think that we've got about a 50-50 chance of getting to Sense 1.0, this 30 years of additional life that reaches this thing called longevity escape velocity, within the next couple of decades, within the next 20 or 25 years. It could take a lot longer, of course. This is very pioneering technology, and no pioneering technology is predictable in terms of time frame. But I think a 50% chance is quite enough to be worth fighting for. Now, it could, for sure, take longer if funding stays really challenging. I think we could lose another 10 years if it stays this way. And that, let's think about it. That's about 400 million lives that we would lose. 150,000 people die each day, 155, something like that. 155,000 people die each day worldwide, of all causes added together. More than 2/3 of them, perhaps 110,000, die of aging. That's a lot of people. That's 40 million per year. So if we lose 10 years, we're losing 400 million people. I'd rather not. Now, think about this from your own perspective. Hands up everyone who thinks they're going to be alive in 20 years. All right. Hands up everyone who put their hand up just now and yet who doesn't think they're going to be alive in 100 years. Well, I haven't been very convincing, have I? All right. But you get the idea, right? I saw that some of you only half put your hands up. Yeah, I was interested in that. All right. Nevertheless, I get the idea. You know, it's pretty hard to believe this stuff, even though, as you can see, it's not just me saying this. I may be the one saying it most loudly, but this is becoming orthodox now. And the reason I asked you that question at that point was because I want to draw attention to the line in red. You're not going to give that answer in 5 years from now. In 5 years from now, Oprah Winfrey's going to be giving you what I'm telling you. And then you're going to believe it, aren't you? Right. So, a large part of the reason why people are so reluctant to believe that this is real is because they kind of wish it weren't. They kind of get terribly petrified about the idea that the world might be so awfully different so very soon. And they think about things like this. They say, oh, where do we put all the people? Or, you know, maybe it'll be only for the rich. You know, the worst of it is, people will say those first two things in consecutive breaths. Now, hello, they are mutually exclusive. If it's only available to the rich, how are you going to get too many people? Come on. And, you know, oh dear, won't dictators live forever? You know, last I heard, dictator was fairly high on the league table of risky jobs. You know, not many dictators die of aging. And like, you know, boredom. Oh, yeah, won't it be so boring not getting Alzheimer's disease and being able to remember everything that, and how we pay the pensions. Well, who gives a damn how we pay the pensions? We're going to be healthy. We won't need pensions anymore. Why do we pay people to do nothing from the age of 65? Why? It's because we're very sorry for them. Why are we very sorry for them? Because they're about to die. And that's not going to be true anymore. So this is not the right way to be thinking about the sociological considerations. This is the way to be thinking about the sociological considerations. No one's going to have Alzheimer's anymore. No one's going to have atherosclerosis or any of the cancers of old age or osteoporosis or any of the things that a lot of you are worried about getting soon. Okay. You're going to be vibrant and vital enough to be able to continue to contribute wealth to society rather than just consuming wealth, which is why people are so scared of the idea of people living longer today. You're going to have the energy to carry on exploring novelty, so you're not going to decide that you've done enough with your life. Because, you know, you don't decide that you've done enough with your life when you get bored when you're young. You go out and find something new to do, and there's always something new to do. You don't have to do the same job for 500 years. You can do it for 40 years and retire for 10 years and then retrain and become a rock star for the next 40 years. I mean, come on. You know, and above all, the thing that I come across the most often when I talk to people and they say that they're scared of getting old is because they're scared of becoming a burden, especially on their own kids, taking away the productivity and quality of life of their kids by prevailing on them to look after them. That's not going to be true anymore. So that's all I'm going to say, except obviously I'm here for Q&A. This is the book I wrote several years ago now. Almost all of this book is about the biology of how we're going about this. It's written for a non-specialist audience in the sense that it doesn't rely on, you know, biology jargon. But saying that, I call it semi-technical because it's very detailed. It doesn't cut any corners. And this is our website and my email address, and you're always welcome to contact us. Thank you very much.
Thank you so much, Dr. DeGray, and I appreciate, so what you're saying is that at a primary preventative level, we can keep the cell healthy to prevent all of the problems that are associated with age-related problems that will ultimately, many of us will die from. So if that's the case, why aren't the drug companies jumping all over this?
The reason why drug companies are not yet jumping all over this is the same reason they never jump on really early stage stuff. Big Pharma just don't do any drug development anymore from the early stage, not preclinical work. They buy up companies that have de-risked it by showing that it works up to like phase 1. It's going to be the same here. We're going to see drug companies and, you know, the medical industry in general jumping all over this, as you put it, like you've never seen before, but we're not going to see it until the proof of concept stuff that people like Sense Research Foundation are doing has progressed far enough to actually make it a value proposition in the short term for shareholders that care more about quarterly balance sheets than they do about the long term.
And I think probably the profit motive there on the...
Well, that's right. I mean, profit is all about risk, right? So you want to de-risk as much as you can.
Mm-hmm. We're collecting some questions for you. I think that there's the issue of you kind of minimize the impact to society. If there were people living far longer, what about younger people? And we have people who are trying to make a living and getting into the workforce, and we've got people staying in the workforce for decades and decades more.
Yeah. Okay. So, yeah, I kind of get a bit heavy-handed when it comes to the societal implications because it's so tedious answering all these questions for the millionth time. But I do take them a bit more seriously than I perhaps indicated. I think there are three levels of answer to concerns about the impact of radically longer lifespans on society. The first answer comes down to looking at the specifics of the concern. So, for example, if people say, oh my God, we're going to have far too many people, then you can actually look at the question. You can ask, well, what's likely to occur in terms of the rate at which population would increase, and how would we fix this? By, for example, increasing the carrying capacity of the planet using other technologies like renewable energy and artificial meat and carbon sequestration and so on and so forth. These are important questions that need to be addressed, but the tendency these days is for people to exaggerate the problem. People will think that, as soon as we get aging under medical control, world population will double in like 10 years, which is complete nonsense. And we had to actually fund a study run by a very authoritative, well-respected group in Denver to actually develop software to simulate what would happen through the next century after the development of these therapies in order to actually prove to people in a manner that they would believe that no, the population increase would be very modest. So that kind of answer is important. The second level of answer is very much more general. It's all about the magnitude of the problem. So overpopulation, well, maybe in a worst-case scenario, we might end up having to have fewer kids than we would like in order to make room for all these tedious people who were born a long time ago and haven't had the good grace to die yet. Right. But hello, at the moment, we've got quite a bad problem with Alzheimer's and atherosclerosis and cancer and so on, and we are pretending to try to do something about it with this pitifully pointless geriatric medicine that I mentioned early on, right? So if we actually think that people who were born a long time ago have the right to good health, then we've got to kind of balance that against the sacrifice that we might, in a worst-case scenario, have to make. And of course, the point you made about turnover in the workforce or allowing young people the opportunity to progress, the same thing really. We might have to restructure society in interesting ways in order to, like for example, tax people increasingly more if they stay in the same job, whatever, creative things like that. But maybe we would regard this as a bit of a bit challenging. But hey, is it worth it or not? To get rid of the problem that we've got today. That's the second level of answer. The third level of answer is, I believe, the most decisive and the most incontrovertible. And it is simply the moral question. Who is entitled to choose? If we say, oh dear, where do we put all the people, overpopulation, pensions, let's not go there, let's not develop these therapies, and as a result, the development of these therapies is delayed, then what we would be doing is we would be condemning a generation, a cohort of our descendants, to the same kind of unnecessarily early, unnecessarily painful death that our ancestors have experienced. Whereas, conversely, if we develop these therapies as fast as we can, then we will be giving our descendants the option whether to use those therapies or not, or how to use them, on the basis of their knowledge of what other technologies have been developed that might offset overpopulation and so on and so forth. So it seems to me to be completely clear that we have absolutely no right to delay, because our descendants are the ones who are entitled to make that choice, and we are not entitled to make that choice for them in our position of relative ignorance about the pros and cons.
So, for example, if we had the capacity to develop immunizations and antibiotics, and if we had withheld that, that would be wrong for society. And if this possibility is here, it's the right thing to move forward with it.
Absolutely. And, of course, the reason why this is a complicated question is because we're talking about it a long time before the therapies are going to come along, even in the best case, at least a decade or two, right? Whereas in general, what happens is that the conversation of this kind hardly exists until, bang, the therapies already do exist, and we have to just figure out post hoc what to do about those therapies. It happened with IVF, it happened with, it's not even just medicine. The Industrial Revolution, you could say the same thing, the spinning jenny just suddenly existed, and, what are you going to do about it?
Is there any, can you get a short-term gain with a disease, a major disease, such as Alzheimer's or something, atherosclerosis? Is there any way to move the clock further on showing some success?
So I wish, all of the therapies that we are developing right now are applicable individually to specific diseases, generally diseases of old age, sometimes actually early life diseases. But the thing is that they're still really difficult to develop. And at the moment, the geriatric medicine mindset that society has and that the medical industry and medical research community have is that even very modest progress against a particular disease is a success. And of course, they kind of can measure it that way, because if you look at atherosclerosis, for example, and you say, well, let's suppose we were able to postpone the onset of heart attacks and strokes, the end stage of atherosclerosis, by 5 years. That's almost as good as curing it, because so many people who would have died of heart attacks and strokes will die of something else in the meantime, like die of cancer or whatever, right? So the proportion of people dying of atherosclerosis will go down a lot, and that's what people who study atherosclerosis measure as success. But of course, it's a ridiculous calculation because the oncologists are doing the same thing for cancer, right? At the same time. We have this Alzheimer's epidemic right now. Why do we have an Alzheimer's epidemic? Because we've been relatively successful in postponing death from heart disease. So more people are getting old enough to get Alzheimer's. The best way to cure Alzheimer's is to kill all the cardiologists. Right. But it's not widely touted as the solution. Right.
Have you thoroughly exhausted lifestyle factors to such as diet and exercise?
So this is a great question. I am all for living a healthy life. Okay, I think that the best, you should definitely not smoke, you should not get seriously overweight, and so on and so forth. But there's two things I want to say about that. First of all, the main reason not to do those things is because if you do those things, then you will have less, if you get seriously overweight or you do anything that's bad for you now, you have less chance of living long enough to benefit from the therapies that we're working on. So that's bad, right? But also, you've got to understand the magnitude of these effects. The statistic I like to use, actually, is with regard to longevity in the USA versus Japan. So a lot of people around the world laugh at the US medical system because it is so utterly inefficient at getting people to live a long time. You spend far, far more money per capita on medical care in this country than anywhere else in the world. And yet, in terms of longevity, if you look at the league table of longevity in the industrialized world, you're down around number 45 or something like that. It's absolutely laughable, right? But the thing is, people who laugh at the USA for that are actually missing the point. Because what you really need to do is look at the actual numbers, not at the league table, not at the ranking. If you ask what is the actual difference in life expectancy between the USA and Japan, number one in the world, okay, hands up anyone who thinks it's more than 10 years. Hands up anyone who thinks it's more than 6 years. Well, you're a more knowledgeable bunch than most. Okay, it's actually about 4 years. Now, 4 years is better than nothing. It's nothing to be sneezed at, but it's only 4 years, right? We're after a lot more than that. And that's about as good as you can get, right? I mean, the Japanese do almost everything right. They do smoke too much, but the fact is they've got a great diet, they don't eat too much, they've got good genes as well, everything goes right for them, and still they're only getting 4 years over the ridiculous American situation.
There's a tremendous efforts being made in the United States towards promoting the healthy lifespan, short of extending human species, which the longevity of human life is believed to be about 120, and your suggestion that life can be extended further than that, how would you describe your work compared to that?
Yeah, okay, so this is a conceptual error that people have made. People look at the lifespans that we see today, and they say, well, nobody lives beyond 120. That must be some kind of natural limit. And of course, that's fine. It is a natural limit for the body as we currently know it, because metabolism creates damage. And different people create different types of damage at different rates, but only within a certain range. Ultimately, damage is caused by the way that the body needs to work. And yes, there are some things that some people do a bit better than others, but the main causes of damage, the main aspects of metabolism that drive the accumulation of damage are, well, the number one is breathing. Breathing is really, really bad for you. But the fact is, it's pretty non-negotiable, really. You've got to do it. But it creates free radicals. That's where free radicals come from, which of course damage DNA and everything. So, of course, there's a natural limit. But it's only a natural limit until we get therapies that can repair the damage that metabolism creates. So it's a complete misconception to say that there's really a natural limit. A natural limit in the absence of medicine is not relevant to the conversation.
I know that we're probably coming up. I'm just going to end on one last question here. Many of you know I do a lot of work in end-of-life planning. And do you see, how do you view death in your work?
I don't think about it very much. I don't have time, to be honest. As far as I'm concerned, I don't have an opinion about euthanasia and other aspects of choice to end one's life when one is in a very bad state of physical or mental health. I don't have any problem with that. And of course, one can argue where the threshold is that constitutes very bad. But the point is, when someone is in the prime of life, in their 20s or 30s, and yet they fancy dying quite soon, then we have a word for that. We call them, suicidal. And, I've never rung a suicide hotline, but I'm fairly sure that if you do, then the first question they ask you is not your date of birth, so that they can put the phone down if you're over 80. Right? It's kind of considered to be a good thing that people are good at changing the minds of people who think they want to die when they're actually doing all right. So that's how I feel about it, really. I feel that we have a duty to give people the best healthcare we can, not just today, but 20 years from now, which involves doing research right now. And therefore, we have a duty to put ourselves into a position where it doesn't matter how long ago you were born, we treat you the same way. If it turns out that means we try to change your mind, if you want to kill yourself, then so be it.
Well, I thank you, Dr. DeGray.